Hello everyone, welcome to Rushi Technologies YouTube channel. This is Balaji Reddy Lachanagari, trainer and director of Rushi Technologies. Today I am going to discuss about the most very important concept as a DevOps engineer or as a developer or a SRE engineer or a cloud engineer. You should understand the differences between microservices architecture and monolithic architecture. So if you are already learned DevOps and not able to crack the interviews and not able to answer scenario based questions or real-time questions, this video is for you. So don't skip, watch the session from beginning to ending. Definitely it will help you to answer the interviews with the confidence. And as part of this video, I will be walking you through what is monolithic architecture and what is microservices architecture and what are the differences between monolithic architecture and microservices architecture in a detailed way, and how we can overcome that challenges that is bringing to the table by that microservices architecture using latest DevOps tools. So you may have a doubt as a DevOps engineer, first of all, why we should learn about this monolithic and microservices. Most of you guys already know this is like a developmental design, developmental architecture, that applications can be developed in monolithic way or a microservices way. But the question here, why as a DevOps engineer or a SRE engineer, why we should be know about the differences? Because understanding the monolithic and microservices differences is very essential as a DevOps guy, because our role is directly supporting how we are building our applications, how we are deploying them, and how we are scaling and managing across environments. So one of the reasons you should know, the deployment strategies also will vary based on the monolithic and microservices application. Suppose if you take an example, you have to design the CI/CD pipelines, branching strategies, rollbacks and rollout mechanisms for application. Deploying a monolithic application is very simple and straightforward. You are going to just take that package like a jar, var, EIR. You are going to just deploy that package in some server. The entire application will be up and running. But when it is coming to the microservices, it is not as straightforward as monolithic. So here you need to have hundreds of pipelines, dozens of pipelines. So for each microservice, you should have a separate CI/CD pipelines. So if you have to design proper, highly available, scalable CI/CD solutions for your application, so you should know the differences between monolithic and microservices. And not only deployment approaches, and most importantly, the infrastructure management and orchestration. Suppose if you are deploying or developing and deploying applications in a monolithic way, you just going to have a server or servers. In that servers you are going to install required configurations. You will just deploy that package. It is very simple and straightforward. But in case of microservices, right, you should be able to understand how we can build and deploy dozens of services. And here, how you can bring the solutions like containers using Docker, container orchestrations like Kubernetes. So you should understand the differences so that you can give a better infrastructure and configuration management solutions. And also monitoring and logging. Suppose if your applications is deployed in monolithic architecture, monitoring is very simple and straightforward. We have a centralized logging mechanism and centralized monitoring. But when it is coming to the microservices, our microservices are distributed across so many systems, so many containers. So we should have a distributed tracing and log aggregation and monitoring for each and every service. So here you can use the tools like Prometheus, Grafana, ELK, and we will be deep dive how all these tools can be integrated as part of this session. And also like configurations and secret management. Suppose if you are deploying applications in a monolithic, you have very few configuration files and environment variables that you can set up easily. But if I have applications developed and deployed in microservices architecture, right, you have dozens of services and each service will have its own configurations and secrets. So here as a DevOps engineer, you should be aware about centralized configuration management tools like Kubernetes secrets or HashiCorp Vault. So to provide the configurations to the services. If you watch this video from beginning to end without skipping, you will get complete idea about what is monolithic microservices. As a DevOps engineer, how you can use all these tools and technologies used in the application for building and releasing applications in a more efficient way. By watching this video, you can completely understand the overall real-time environment and real-time projects, how it works. With the confidence, you can answer in the interviews. By looking this video, you can implement these solutions in your actual projects if you are already a DevOps guy. So enjoy watching this video. Thank you. Monolithic application architecture versus microservices application architecture or a microservices architecture. Monolithic architecture or microservices architecture. So what is this monolithic and what is this microservices architecture? We'll try to understand. So this monolithic or microservices architecture is a developmental architecture, developmental technique or developmental architecture. Any development team, any application team or any development team can develop the application as per the requirement in a monolithic architecture or microservice architecture. So if you take any application, each application will have some kind of a modules or a features. If any application is developed in a monolithic architecture, that application will have single code base. All the modules or all the services or features is in same code base, and we are going to have a single executable or a deployable package. If we deploy that package, entire application will up and run. You take any application, each application will have a modules or a features, right? Let's take maybe you take this application like maybe Walmart, just to give an example, or maybe let's take the application like Flipkart. So this application will have a lot of modules or features. So using this application, we can register into this application. To use this application, we can do the registration. Registration is one module or a feature, and once we register or create account, you can consider this as a create an account, or we call it as a sign up registration or sign up, basically create account. So you can create an account in Flipkart, that is called as a sign up or registration. Then we can log in to the Flipkart. Then login is one module, login is one feature. Similarly, you can check out products, browse or check out the products, right? E-commerce application, right? So Flipkart is making some products available so that you can check out and make the payments and buy. So check out products or browse, and whatever products you wanted to buy, you can add to the cart. You can add those products to the cart, and you can make a payment. Add to cart is one module. Payments module, you can make a payments using UPI, credit card, bank account, and you can track the orders, right? And you can manage your profile like address, delivery address, and promotions means offers, right? Flipkart is going to give some kind of offers. You can see what offers are there, promotions like this. You can take any application or a product, they will have so much of services, and here you can have an inventory means stock. So Flipkart has products and product detail, check out products, product detail, PDP, product detail page, like that. So product details and inventory like this. You can see any application or a project you take, each project or each application will have a modules or a features. You can consider this is one feature, this is another feature, this is another feature, this is one more, like that. You take any application, you take any project or any module, I mean to say, you take any application or project that is implemented as per the requirement, and each application or a project will have a set of modules or features. So this application can be developed using any programmatic language in a monolithic architecture or a microservices architecture. These type of applications typically three-tier architecture they will follow. There will be a GUI, there will be a APIs in the background, databases. So there is a GUI. For login also you have a GUI. For registration also you have a UI. You will check the products. You can see the detailed information about the product. You can add the cart, make a payments, orders profile, like that. So you can consider this as a GUI. This as a GUI, right? So this is a UI. Here you can see you can create account, you can log in. If you don't have an account, you can create an account. This is like a UI. And if you already have an account, you can log in. This is like a checkout. You are checking the products and what product you want to see. If you click on this, this is like a detailed page, product detail page. And internally there are APIs. This GUI is internally making a APIs to get the product price, whether this product is there in the stock or not. Then you can add to cart, you can make a payment, you can like all these are like a modules or a features as per the requirement that application can be developed, right? So there is a GUI. Basically this GUI is developed using HTML, CSS, JavaScript, nowadays React.js, like that. This GUI will internally make a API calls. This API, application programming interface, they are going to take REST APIs, RESTful APIs. So these APIs are developed in programmatic languages, backend code using Java with some framework like Spring Boot. You can develop, or maybe using Python with Flask or Django. We can develop. Otherwise, you can use Node.js with the Express framework, or maybe you can use Golang. There is one programmatic language called Golang, or C sharp, that .NET. So using those any of the programmatic languages, we can develop the APIs. These APIs will internally talk to the databases where we are going to store the data, retrieve the data, update the data, delete the data. So there is a databases where there is a data about the products, the product and what is the price and who is going to supply that product, and orders details, payments details, users details, promotions details, all these things will be there in the data. So these APIs can internally talk to the databases. These APIs can be internally talk to the databases. So the databases, again, we have different types of databases, like relational databases and document oriented databases. Like relational databases are storing the data in a tables and columns format, and one table will have a relationship with another table, like a primary key, foreign keys. Tables and columns format and relational databases will have a relations between one information to another information. Example for this, MySQL, MySQL we call it, Oracle, PostgreSQL, and MariaDB, Microsoft MySQL Server. IBM DB2, IBM DB2, etc. Otherwise, nowadays people are using document-oriented databases. The data will be stored as a JSON document itself, right? Key values data, no columns and the tables format here. So like MongoDB. Similarly, we have other like Couchbase, Cassandra, etc. Now, this is the implementation. This is the implementation. The UI of the project can be developed in this, and the APIs, this sign up also there is an API, login also there will be an APIs, browse products, product details, add to cart, payments, everything in the background. APIs, REST APIs. These APIs will like a CRUD operations: create, read, update, delete. These APIs will take the data from the input UI, like the user is giving the input via GUI. That GUI will take that input and pass that input to the APIs, and that APIs will take the data, process the data, validate the data, and persist the data. That so this application can be developed in a monolithic architecture or a microservices architecture. If this application is developed in a monolithic architecture, old, right? So that application will have a single code base. What do you mean by code base here? Single code base means only one SCM repository where there will be a code for all these modules or all these features. Let's say, let me explain this way. This is the development team, application team. There might be a UI developers here, and also UI. UI means that front end developers who develops the front end code, and there might be a backend developers. Backend means that API, backend or API developers who develops those APIs, like Java developers, Python developers, like that. There might this application team, right? Here, this application team will have a UI developers who can develop the UI, or front end developers we call it, and there is a back end developers or API who develops those APIs. That APIs has the business logic, and these guys will develop the code respectively in their local systems, local servers, local laptops basically. Then they will commit that code into the centralized SCM repositories like GitHub or Bitbucket. We can use here. They will create a repositories, SCM repositories. They will maintain that code. So in case of monolithic architecture, all the code of all those modules or features will be part of same code base, same SCM repository. Here itself you will have that HTML code, CSS code, JavaScript code, and also the Java code if the APIs are developed in Java. If it is developed in Python code, everything will be here, including the respective build script like pom.xml, like that. So that monolithic architecture will have a same code base. In this only all these modules, in this only we have all these in this only we have all these modules, or all these modules code is part of the same code base. In this repository only, all the modules code will be there. So in this SCM repository only, all these modules, all this code, all these modules code will be part of same code base, single repository. Same, all these modules code is part of the same repository, right? It will have a single code base with all the module source code. From this code you can create a deployable or executable package like a jar, var, tar, like zip file. So from this using builder tools, if it is developed in Java, maybe Maven will be used as a build script. So maybe you will take this code, and from this code you will build a package. This is like a deployable or executable package. Deployable or executable package. It will have a single executable package like a var or maybe tar or zip, based on the programmatic language. Based on the tool, it will have a package. Now here, if I deploy this package, that will have all these modules code compiled, and all the modules code will be part of this UI code as well as that APIs code. Everything will be part of same code base. So if you see, we have some advantages with this, and we are going to have some kind of a drawbacks also. So here, if you see the monolithic architecture, the monolithic application, the monolithic application has a single code base with multiple modules. Modules are divided either based on the business functionalities or based on the technical functionalities. The modules are categorized, but it will have a single code base with all the modules code. And it will have a single build system which will build an entire application with its dependencies, and it will have a single deployable package. So here, in case of monolithic architecture, user interface, user interface is like a GUI, and this business logic is that APIs, and the data interface is nothing but the code that is responsible for talking to the databases in the background. So this UI code, business logic, that data interface is nothing but that is also a code which will talk to the databases. All this is part of the same code base, right? It will have in a single package, you have UI code, business logic, data interface, everything. And this will internally talk to the database we will deploy in a separate system, but the GUI, that APIs, will be running in a same system, single package. So here we have some kind of a challenges and also advantages. So what are the advantages? With this monolithic architecture? The advantages, if you see, it is easy to deploy, simple to develop because it has a single code base, simple to deploy because we will have a single package. All you need to do is you can take this package and deploy that package in some server. With the required softwares and configurations, you can deploy. Let's say here you created a package like this. Then what you are going to do, whether you are going to manually do or via pipeline you will do, you will have a servers, physical machine or a virtual machine, that can be non-prem, or a cloud, that doesn't matter. Then here you will have some OS, that can be any OS like Linux. In Linux again, Ubuntu, Red Hat, CentOS, whatever. But before deploying this application package or application code, right? Maybe what you will do, you will install required softwares like Java and like Tomcat or JBoss or WebLogic, whatever, and you are going to configure required configurations or settings with required environment, and you are going to deploy this package. This code you will deploy here, that like a var, tar, whatever it can be, like that can be a var file or a tar file or a jar file, like that. You are going to deploy, it will have everything. Whatever is required for your application to run. It has everything, all that UI code, HTML code, or that backend code, like that. And you will make sure if there is a database running somewhere, that can be again in on-prem or a cloud, or maybe that can be self-hosted database or fully managed database by cloud, like that. So here you will have a database software, and this application will talk to the databases for storing, retrieving the data. And if this application maybe internally might talk to other applications also, third-party applications like a payments. You are giving a payment details, right? This may talk to another applications to take the payments third party. Otherwise, this application may talk to another third party applications also to get the product details, like price details also, like that. Maybe this application may talk to the databases for storing and retrieving the data, and maybe this may talk to third party applications like payment gateways to talk to get to take the payments, right? But in real time, you are not going to deploy this application in a single server. It will talk to the dependent applications also internally, like payment gateways or any other third-party applications. It will talk. But this we are not going to deploy in a single server because it's a single point of failure. And also, if the so much traffic comes, here again, the application may crash or that application performance will be degraded, slow. So here we are going to replicate this application into a multiple instances or a multiple servers for high availability and load balancing. You will distribute, and you will bring a reverse proxy. To the distributing the load. This application will talk to the databases or third-party applications like this. But in front of this, you will bring a reverse proxy or a load balancer. Basically, that can be hardware load balancer, software load balancer, a cloud-managed load balancer, based on what you are configuring. So here, this is like a load balancer which will distribute the load, among these servers. You will have the load balancers will receive the traffic on a secure port, and any request comes to this load balancer, it will distribute the load to this server or this server. Like that, you will have a multiple servers based on the demand. You can increase and decrease. And also, this load balancer will have an IP address. That public IP. This IP will be mapped. Let's say this is the load balancer IP. This IP will be mapped with DNS domain name, internet DNS, right? You have a DNS servers or a DNS services. There, here in the DNS, you will have this IP mapped with the domain. Just to give an example, let's say flipkart.com. That is the domain name. Just to give an example, flipkart.com is mapped with this IP address. The end customers are end users. What they will do, right? They will use this domain name. Let's say you are an end user. The end customer. In their systems, what they will do, they will go to the browsers and they will type flipkart.com. So request will go to DNS resolver. We already discussed all these things, right? So request will go to the DNS resolver. DNS resolver will talk to the DNS root server. Root server will give the TLD server details. TLD server will give the name server details. The name server will return the IP address. The name server will return the IP address of that domain. Then request will go to that system. From end user system, request will go to that system. That is like an internet facing load balancer. Then this load balancer will internally talk to this application. UI will internally again talk to the APIs. That APIs will talk to the databases or third-party applications like this. So this is how typically the monolithic application will work. The advantages with this monolithic: simple to deploy because it's a single package with all the code, UI code, APIs code, data logic, and it is easy to test also. All you need is whenever there is a change in the code, you are going to create a package. That package, if you deploy only one package, if you deploy in these servers, if you make sure this is having a network with the database and database is running, then you can test entire module, entire features. it is easy to test. All you need is you just build a package and deploy that package and make sure there is a database running and the network is there to the databases. Then you can test entire application, entire mod, all the features of the application you can verify as a testing tester also. It is easy to test. And again, it is easy to debug or trace the errors. In monolithic architecture, it is easy to debug and trace the errors also. It is easy to debug and it is easy to trace the errors. Now, whenever any customer is accessing, right? Let's say I am trying to select this. I logged in. I logged into my account, right? I logged into my account. Let's say something like this. I have logged in, just giving some phone number, my details. I will get an OTP and I can log in. So I already have an account. I will log in. A OTP I got in the background. There is an API. This GUI is making a API call, and I selected this product. Right? I wanted to get it for my address like this. Let's say I will check again. Everything is an API, and they're saying okay, it is there. I am buying somewhere here. I have selected some address like this. Let's say I have I said deliver here. Continue like that. Somewhere the request is failed. Maybe while adding the product, or while updating the address, or while making a payment. While making a payment, somewhere the request is failed. But how we have to trace these errors, right? So here everything is running in a same code base, right? All the modules are in a same instance or a same process it is running. Maybe my request may go to this server, maybe the request may go to this server, or maybe this server, but this applications will generate some logs. That logs will be part of the system. Maybe somewhere that log file will be there. That Flipkart will generate logs. That log file will be there. If I go to this system log file, or maybe if I go here and if I go here, maybe if my request went to this server, or maybe this server or this server, I can go to the respective server, and if I check this file, I can trace entire request. Login has done successfully, product selection has done successfully, updating address has done, but somewhere the request is failed, payments failed. So you can check this log maybe in this system, or in this system or this system. It is easy to debug and trace where exactly it is failed, because everything running in a same process, right? Login, registration, payments, everything in a same process, same package, same process. So it is easy to debug or trace the errors. That application will generate the log, and if I go to that log file and I can easy to trace the errors also here in this monolithic architecture. We have some advantages, but more than advantages, there are a lot of challenges or drawbacks. There are a lot of challenges or drawbacks here. So what are the drawbacks or challenges with this monolithic architecture? What are the challenges or drawbacks with this monolithic architecture, where you are developing entire project as a single project, all the modules or all the features as a single project, and all these modules code is in a same code base? What are the challenges or drawbacks here? What do you think? What are the challenges or drawbacks here? So the challenges or drawbacks here: difficult to understand and modify the code. Difficult to understand and modify the code. So you are having a single code base with all the modules. You have a single code base with all the modules. So you have a huge code base. There is so much of source code. There is so much of source code. Hundreds of files will be there, and again, each file will have so much of lines of source code. Suppose as a developer, if any new developers joins that application team, or existing developers also, if they have to do some kind of a bug fixes or some kind of a enhancements, it is very difficult to understand the source code. It is very difficult to understand and modify the source code. And here it is tightly coupled. Here it is tightly coupled. Tightly coupled means Tightly coupled means here all the modules are in a same code base. All the modules are in a same code base, same package. They are tightly coupled. They are not loosely coupled. We have to redeploy entire application on each update. Let's say you have some enhancements to the login. You wanted to make some changes to the login or maybe registration. So let's imagine earlier, currently, we can log in using only email address. Let's say we have to enhance that. We can log in. We have to support login to the application via mobile number also, phone number. You are making some enhancements. That application team is making the enhancements and they done the changes to the code which will allow us to log in via phone number and they will commit the code. Here you are doing some kind of enhancements or bug fixes. Even though you are making some changes to only specific module or a feature, you can't deploy only that feature. You have to rebuild. You have to rebuild entire application. You have to rebuild this because all the modules are in the same code base. You have to compile and create a package. Entire module you have to rebuild and you have to deploy in a lower environments and you have to retest all the modules, even though you are not making changes to the other features. But say since it's the same code base, if you are modifying some common code, it may indirectly impact other modules. So you may need to rebuild, redeploy, retest the entire application again. Even you are making a changes to the one module or a one feature for doing enhancements or bug fixes, you need to redeploy and rebuild and redeploy entire application on each updates. And again, single bug also can bring down the entire application. Single bug also can bring down the entire application or entire application. Even though there is a small bug in the registration, let's imagine registration is not working as expected, there is an issues and it is failing, but you wanted to fix that bug and you have to deploy. You can't build and you can't deploy only registration module or a feature. You have to bring down your entire modules or all the modules because it's a same code base. You have to bring down entire application. You create a new package. Again, you delete the old package and deploy that package in the servers like production. So you will single bug also can bring down entire application with this monolithic architecture. It is not possible for us to deliver without impacting other modules or other features. It is not possible for us to build and deploy only specific module or a specific feature because here all are tightly coupled in a same code base and same package. And again, scaling the application is also difficult. Scaling the application also difficult. Suppose if you wanted to scale only some modules or features, it is not possible. Let me tell you here, maybe there is so much traffic coming to your application, but not all the features have a load. Just to give an example, so many people will log into the Flipkart. Example, I am taking Flipkart, and so many people will check out the products. They will add the cart, but they will not place the orders. They will not make the payments. Here, your application is getting the traffic, but only few modules is getting the traffic like login, check out products, product details, add to cart, but they are not making the payments. They are not doing the orders. Here so much traffic comes to the login or products like that. Now if so much traffic comes to the application, each instance will have some kind of a capacity, hardware capacity, like CPU, memory, storage, like that. As I already said, if any application or any process is getting the traffic, that application or a process will consume CPU and memory from that system, hardware resources. If any application doesn't have enough CPU, that application or a process will become slow, hung. And if any application or a process will run out of memory RAM, that process will be killed. OOM killed, process will be killed. If the process is stopped or application is stopped, again the load will be increased on another servers, and this will also crash, this will also crash. Finally your application will be crashed. But here you have to scale, but you can't scale only specific modules or features. Suppose you are going to replicate the application in one more instance, but here is it possible for me to replicate only login, only registration like that? No. Here this package has all the modules or all the features. You will end up scaling entire application. You can't scale in and scale out specific modules. Suppose again there is a lot of traffic to the only registration. Again you are going to replicate one more instance, and you are going to add this instance to the load balancer so that load will be distributed. But here you will end up scaling, entire application. You will end up scaling entire application or entire module. Let's say there is a less load, again you will scale down. That time you will delete these servers and you will scale down. You will remove that from the load balancer also, like this. So you will end, if you wanted to scale in, you will end up scaling entire servers, or if you wanted to scale down also, you will delete all the, like this. So here you can't scale individual modules or features. You can't scale in, scale out specific module or a feature here. And again, changes in one module or one feature may impact the other module or other functionality, because you are using a common code base. If you are modifying some source code for fixing one problem, indirectly it may cause problems in another also, because if the same common code is used in all those modules or features like that. So these are the challenges or drawbacks with monolithic architecture. I hope you are having a clear understanding about what is this monolithic architecture, what are the challenges with monolithic architecture, and at the same time, what are the advantages with this monolithic architecture. Now, to overcome these challenges or drawbacks that is because of the monolithic architecture, later there is a concept of microservices came. There is a concept of microservices came into the picture. There is a concept of microservices came into the picture. This microservice architecture became more popular from early 2010. So before 2010, like most of the applications were running as a monolithic architecture only. Even when I started my development, I joined as a Java developer in 2009. I was working for so many applications. I was a Java developer. APIs I used to develop for so many applications. We used to follow that monolithic architecture in 2009, 2010, somewhere in 2011, 12 also. The old projects or legacy projects were still developing the applications in a monolithic. But we used to have these challenges or drawbacks. But this microservices architecture, this is developmental architecture. That application team, that development team can follow this microservices architecture. This microservices architecture becomes more popular starting from 2012-13, and I was working as a developer in 2013, 14, 15 also. We used to develop the applications in a microservices architecture. So what is this microservices architecture? How different it is from monolithic? Let's try to understand in a detailed way. I am going to explain in a detailed way, not at high level. So this microservices architecture, also developmental architecture, the developers can develop the applications in a microservices architecture. The name itself, it is saying micro means a small. So microservices is a software developmental architecture or a technique. We can develop an application. We can develop a single application as a collection of loosely coupled applications, so many, right? In a microservice architecture, microservices architecture is a developmental technique. We can develop an application as a group of loosely coupled services. You can think login also one service, registration one service, products one service, payments one service, like that. So here in a microservices architecture, we can develop an application as a collection. Collection means group of loosely coupled applications or services. Here, each service, here in microservice architecture, each service can be developed, deployed, maintained separately, independently. Here, each service can be developed, deployed, and maintained independently from others. And again, each of these microservices is responsible for specific tasks. Here, login microservice is responsible for only performing the login related activity. Registration microservice is responsible for performing only registration related tasks. Payments microservice is responsible for only making the payments, taking the payment details from customers and talking to the bank APIs and taking the payments. And order related microservice is responsible only for tracking the orders. How many orders are there? What is the status of the order? Like that. Here, registration microservice is responsible for only performing registration related task, right? And the login is responsible, login microservice is responsible only taking the usernames and passwords and check whether that user exists or not, like that. So here, in a microservices architecture, or a microservices architecture is a software developmental architecture. Here we can develop an application as a collection of loosely coupled services. Each microservice can be developed, deployed, maintained independently from others, and each of these microservices is responsible for specific task. But again, each service can internally communicate with other services via APIs to solve the large problems. At the end of the day, at the end of the day, all these services has to work together. Even though you are developing login separately, registration separately, payment separately, order separately, like that, at the end of the day all these services has to work with each other. Even though you are developing separately, but at the end of the day all these services has to work with each other. That's what I am trying to say here. Each of the microservices is responsible for performing a specific task, but they can communicate. Each microservice can communicate again with other microservices via APIs to solve the bigger complex business problem. So API internally, you are check out, you are selecting the products. That products microservice can internally talk to the inventory microservice to see whether we have a inventory, whether we have a stock or not. And again, when you are trying to make a payments, right, maybe you are going to that payments microservice may internally talk to the promotions microservices. Is there any promotions or offers? So it will apply the offers also if there are any. So like this, internally each of the microservice is performing a specific task, but each microservice can talk to other microservices to solve the bigger problems, bigger business problems here. So microservices is a software developmental architecture that can, we can develop an application as a collection of loosely coupled services. Each microservice can be developed, deployed, maintained independently from others. And each of this microservice is responsible for performing a specific task. And each microservice can internally make a REST APIs, REST calls, right? REST APIs, even though they are developed separately, deployed in a separate systems also, internally API to API communication can happen to solve the bigger problems here. So here, let's see how it will work. Now, let's say this is a monolithic architecture. Now, let's say if the applications are being developed in microservices, how it will work in a microservice architecture. Here each module or each feature will be having a separate code base. So here you will have a separate code base. Separate code base means SCM. Separate code base you will have. So let's say here your UI code. Let's say this is your SCM repositories. You will have a multiple repositories. So let's say this is your repository. Let's consider Flipkart application UI. UI means HTML code, CSS code, JavaScript, that GUI. Here you will have separate SCM repository for only UI, CSS, JavaScript, React JS files, that all those images, audio, that images, whatever, like a static content. So you will have a separate SCM for UI. This is one microservice. This is like UI is a separate code base, right? And here you will have a login microservice, separate code base. This login microservice, this is like a API. This API will take input as a email address or a phone number. Then it will take the password like that to authenticate. So this will have a API like login. It will take the input like phone number or email or OTP or maybe password. Just to give an example, you can consider like it will take input as a username and a password. Then this will internally talk to some kind of a database where we have that user's information. It will check whether we have a user with that username, and whether we have the username is correct and password is correct. Once it is verified, this API will internally talk to the database to identify whether we have a user exist or not, whether correct credentials given or not. Once it is validated, the login can happen. But here only login related. Similarly, this is one more microservice for the same application. Let's say registration or a sign up. Here you will have a registration related APIs. Registration related APIs. It will take like first name, last name, email address, phone number, and your address, right? Office address, home address, first name, last name, email address, like that. It will take all that input, and this microservice will internally talk to the. This microservice will internally again talk to some kind of a database where it will store that user's data, like first name, last name, email address, phone number, and the physical address, home address, office address, like that. This microservice. Similarly, this is another microservice like a checkout. So here this will have a like a search products. Here you are going to search products with some name, like you are giving product name, right? In the UI, let's say here you are just giving like mobiles. In the background it will make API, guys. Suppose here, let me show you. I am clicking on let's clear this. Let me click on search here. So here in the background it is making so many calls. Here you can see this is one API call. This is one API call. Like it is making a API call with some kind of a input. It is making some kind of a API call with input. So it is giving a request payload like a data. So here we are searching some kind of a product, right? We are searching some kind of a product. Here you can see this is one API, like a get call, post call with this payload. Here you can see the payload. It is saying I am searching mobiles, like that. So this is one API. This API will internally talk to the some other APIs also, like inventory API, products API. So other microservices, and they will see the product, whether it is there in a stock and what is the price, like that. It will get and display. So this is one more microservice like that. And this will talk to internally other microservices, like you may have a inventories. Flipkart, one more microservice called inventory. So this will internally talk to the systems and databases whether we have that mobile in the stock or not. And PDP means, suppose again if I click on this one, it will make a one more API call. It will get that detailed page about detailed information about that. That is one more microservice, like a product detail. So here each module or each microservice, I meant to say each module is developed as each feature is developed as a separate code base. Here you will have a product my detailed page, like that. So here each microservice will responsible for doing a specific task, but each microservice can internally talk to the other. So this microservices, this can be developed in Java, Python, or Node.js or a Go language, whatever. And you will have a orders microservice to see how many orders are there, how many orders he has placed. And similarly, payments microservice. Like this, each will have a separate. Here, payments related, it will take UPI IDs or credit card details, and this API will internally talk to some other third-party APIs and take the payments. Here you will search the orders, how many orders are placed. Here product information, like that. These are like inventory, stock, like this. Here each module or each separate code base. Here now the UI developer will work on the UI, and they will interact with this microservice, this SCM repository, and they will only focus on the UI code. And whoever is working on this microservice, let's say some developers are some backend developers are working on this login related. They will work on this. They will work on this requirement, and they will develop this microservice. Maybe this one more team may have a for registration, they are working on this module, they will work on this, like this. These are like a application team or a development team is developing those services, microservices. Back end developers, front end developers, like that, they are working on this here. So that is what I am trying to say here. So microservice architecture is a developmental technique. We will develop that application as a collection of loosely coupled services here. Each microservice can be developed, deployed also, maintained also separately, but each of these microservices is responsible for a specific task, and they can communicate with other microservices to solve the large problems here. If you see this diagram also, you can understand here. If you see this diagram also, here your user interface is separate, GUI, right? Anyhow, for end customers, only this UI matters, but this UI internally can talk to this microservice, maybe login microservice, maybe this can talk to the registration microservice, this can talk to the product search, this product search can internally talk to the inventory, this can talk to the respective databases and get the data. So here each feature you are developing separately. But what are the advantages? What are the advantages with this microservice architecture? What are the advantages? So whatever challenges you had in a monolithic architecture, whatever drawbacks we had here in a monolithic architecture, these are the challenges or drawbacks we have. This becomes advantages in a microservices architecture. This becomes a advantages in a microservices architecture. So here in microservices architecture, the advantages is loosely coupled. Here it is not tightly coupled. Here your code is loosely coupled, your services are loosely coupled. Each has a separate code base, you can build, you can deploy separately, and it is easy to understand and easy to modify the code. Here it is a small code bases. Here this SCM repository will have only UI code. This will have only login related code. This will have only registration related code. This will have only checkout related code. So it is a small code basis. Whoever is working on these services or microservices or these services, they can easy to understand, easy to modify the code, because we have a small code base, right? Separate services. And here better deployments. Here each service can be built and deployed independently, right? Let's say you are trying to make some kind of a changes. You are trying to make some kind of a changes to the UI. So you can build this package and you can deploy only this package in some servers or systems. You can deploy only this package without, if there is a changes to this code, you no need to compile this code, you no need to create, you no need to build and deploy this one, you no need to build and deploy this one, you no need to build and deploy this one. If there is a changes to only this, you take this code, create a package and deploy in whatever systems you already deployed that UI code. Suppose let's say there is a changes to the registration. Earlier registration is supporting with the email address only. Now they wanted to support registration with phone number. Let's say these guys modify the UI, they have modified, which will take the email address along with the phone number also. At the same time, the APIs, this APIs also has to be modified, because it has to take the phone number and it will validate that phone number and it has to support. So let's say there are changes to the registration. So here you can only create a package for this code and you can only deploy this package wherever you wanted to deploy this registration already deployed. So you no need to rebuild this one, retest, you no need to rebuild, you no need to rebuild and redeploy. So here you can build and deploy each service separately from others. You no need to rebuild, redeploy entire services here. So better deployments as each service can be deployed independently, and here each service can be scaled independently because it's a separate package. Each service can be scaled independently. Let's say there is a so much traffic coming to there is a so much traffic coming to the login, or there is so much traffic coming to the registration. So let's say this login and registration code package, these packages you have deployed earlier in 3 servers. Now you can scale this only login by replicating in 4 servers, 5 servers, or maybe this registration also. Earlier it is deployed on only 3 servers, but there is a so much traffic coming to registration. Then you can scale registration only to 5 servers, 6 servers, and other modules, other packages, only lesser replicas only. So you don't need to scale this one. Maybe only this one you can scale to 4, 5, 6, like that, by replicating this package into multiple systems. But here this only less replicas. This will have a more replicas. Here it is possible to scale in, scale out specific modules here. And again, without bringing the entire application down. Here, without bringing the entire application down, you can deploy only specific modules also. Let's say there is a changes to the registration, but I no need to bring down all the modules. Here I no need to bring down all the modules here, right? I no need to bring down all the modules here. So we can bring down only specific modules. Only specific modules here. We can bring down only specific modules here. Let's say registration, you are making the changes without impacting existing customers. Existing customers can still access the login, they can check out the products, they can make the payments, they can place the orders, and they can track the orders. Only registration you can build, registration you can make the registration service down in whatever servers you have deployed that registration. You just start that registration service and you just redeploy. So without bringing entire modules or entire application, you can build and release specific application also. You can scale the specific service also. Here again, each service can be developed using any new technology. Here each service again can be developed using any new technology, because it's a separate code base. What I am trying to say, suppose you have a Python developers, you can develop this login related microservice in Python. Suppose you have a Node.js developers, they can develop this sign up related services in Node.js. Let's say you have a Java developers, they can develop this checkout related microservices in Java. Suppose you have a .NET developers, they can develop this microservices in .NET. So here each service can be developed using any new technology or new programmatic language, because it's a separate code base. But you may have a doubt, sir, internally you are saying this login, maybe this microservice will talk to other microservice, right? Let's say this is your product microservice. That product microservice has to talk to the inventory microservice to see the stock, whether we have a stock or not. But let's say if this is developed in Java, this is developed in other programmatic language like Node.js, but how they can communicate? Here, APIs, REST APIs, the data will be transferred. I mean to say the communication, the data will be exchanged between one microservice or one application to another microservice or application here in a JSON format or XML format like that. So the request will be sent in a JSON format. The response also will get in a JSON format. So the microservices developed in any programmatic language, they will use a universal data serialization like a JSON, XML like that. So they can understand the data and they can use the data. So here, each microservice also can be developed in any new programmatic language or a tool here. So these are the advantages with the microservices that we don't have in a monolithic architecture. But the way it is bringing lot of advantages, similarly it is bringing lot of challenges also here, guys. Lot of challenges also here. It is bringing lot of challenges, but how we can overcome those challenges here? How we can overcome those challenges here? Let me break down again step by step. First and foremost problem here, deployment. So earlier only one package. Previously, all your UI code, your all this backend code in a same package. So deployment was easy. You are just creating one package. You are taking that package and deploying that package in some servers with required softwares and configurations. You have deployed. Here you are deploying only single package. But now let's consider in microservice architecture, it is not a single package. You will have a separate package to be deployed for UI, separate package to be deployed for this microservice, for this separate package. Like so many services you have to build and so many you have to deploy. At the end of the day, all these services has to be deployed so that entire application will work. Let's say again deployment challenges. You can, so many problems comes here. So here if you are manually deploying, so much time, you need to get this code and create a package. You need to create a package, separate package for this one that will have only UI code, and you have to, so here you have to build separate package for this, separate package for this, separate package building. You have to build this. Again, manually building will take so much time and error prone also. Manually building, I mean to say integration, manually integrating, deploying these packages will take so much time. And also, you can overcome this via some kind of a tool. So this is how the technology got evolved. You can use continuous integration tools like a Jenkins, Bamboo, Circle CI, Travis CI, Git actions like that. Let's say you can create a pipeline for this microservice, right? You can create a pipeline. Maybe if you are using Jenkins, you can create a Jenkins pipeline. In this Jenkins pipeline, you will have a steps or stages where it will take the code, create a package, and store that package in the artifactory wherever you want it to store, like that. And maybe for this one also you will have a CI pipeline. So you can have a build triggers like a webhooks. You can create a webhook for this SCM repository. This will trigger, like for building, integrating the changes, right? Whenever the team is making the changes to this respective microservices, you can overcome manual. You don't want to do manually. You can have a pipelines. Like for this repository, separate Jenkins pipeline. For this repository, separate Jenkins. This repository, separate Jenkins. So whenever there is a change in this code, the pipeline created for this microservice, it will only build this package. Whenever there is a change in this code, the pipeline created for this microservice, it will only create this package, like that. But instead of manually building these packages and integrating those packages, right, checking the code quality, getting the latest code, checking the code quality, creating a package and pushing that package to the Artifactory, that continuous integrations. Instead of manually doing, you can do via pipeline. Okay, integrations okay, but what about building? Okay, deployments will still problem. Let's assume you are deploying these applications in a virtualized deployment. Let's say you are deploying these applications in a virtualized deployment. There again so much problem. So let's say here you have 10 packages, almost. Let's say how many microservices? Let's say imagine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus that UI is separate now. So total 11 microservices you have for that application now. So let's say 11 microservices you have. Let's say you wanted to deploy this let's say you are trying to deploy this in a virtualized deployment, virtualized deployments, virtual machines. Here last time when we developed in a monolithic architecture, let's say for high availability and distributing the load, you deployed in 3 servers, one replica, second replica, third replica, because at any point of time, at least you should have some servers to serve the traffic. But last time, everything in a same code base, so all are running in same process, but you deployed that application in 3 servers. But now here, separate now. Now this package separate, 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 like that we have. Let's say total 11 microservices. Now let's say you have to deploy this in a virtualized deployment. For each service minimum you need 3 replicas. For each service minimum you need 3 replicas. Let's say in that case, if you are deploying in a virtualized deployment, how many servers we need? Each service at least 3 replicas you need, and there are total 11 microservices. If you are deploying in a virtualized deployment, 11 into 3, at least you need minimum 33 servers, right? So each microservice 3 replicas, and each microservice you are having a 3 replicas. So you need 3 servers for each service minimum. Let's say so you total have a 33 servers, the 33 machines. Let's say this is one machine. Here you will have some OS. You will have some OS, and here you will deploy, you will install required softwares. Let's say for that microservice, let's say you wanted to deploy this UI. So maybe this UI you can deploy in Nginx or HTTPD, only that UI, right? Separate that you are deploying, you install required softwares and configurations here for that UI. Required softwares and configurations you have done, and you have set up the required environment, and you have copied that package, that HTML, CSS, JavaScript. This can be done directly in the Nginx, like that. But this UI will internally talk to the APIs. That APIs we will deploy in a separate server. But for high availability, maybe you need 3 servers for this microservice. You need 3 servers for this UI, right? Similarly, this login. Let's say you have built. There are so many servers you have. Let's say this is your UI. So you have replicated in 3 servers. But here deployment also multiple servers. Okay, you can, instead of manually creating a package and pushing that package and deploying, this package can be deployed via pipeline also. The way you have created a CI pipeline for getting the latest code, creating a package, pushing the package to the Artifactory, then you can create a pipeline, or maybe in the same pipeline you can have a other stage where this package can be deployed in this server, this server, this server. But deployment you can overcome, but you need more servers. And similarly, this you have to deploy. This you have to deploy. Login also, let's say you have deployed in 3 servers like this. Let's say this login related microservice also you have deployed in 3 servers. This login also deployed in 3 servers, this registration deployed in 3 servers, and this payments deployed in 3 servers. And there will be, again, internally you have some kind of a internal load balancers also here. Internally you need some kind of a internal load balancers here, because this UI will talk to this APIs, login related it will talk. So each microservice again requires some kind of a load balancer to distribute the load among them. This UI code will talk to this internal load balancer. This will distribute the load to the login. Similarly, there will be a load balancer for registration internal. The end customers are not going to use this. End customers will access only this UI, but this UI will internally communicate with all these services again. The code, the APIs will be there. But here you have a more servers, and you need to configure so many servers, and you need to, like, communication problem will happen, more servers here like this. Let's say you need to have more servers, like if you are deploying in a virtualized deployment, right, you need 11 into 3, at least minimum 33 servers. But you can scale independently. Let's say there is so much traffic coming to this login, you can only scale the login. You create another instance and deploy that for login 4 servers, 5 servers, like that you can scale this login related. But here you need to have a more servers if you are deploying in a virtualized deployment. But deployment you can do automation via pipeline. You can have that pipelines will take and deploy. This pipeline will create this package it will deploy in these servers, like that. But here the problems is more servers, maintenance also comes into the picture. So many servers and so many operating systems. If you are using enterprise operating systems, so many OS licenses you need here. And if you wanted to do some kind of a OS patches or a version upgrades, again so much maintenance task will be there here. And not only that, let's say configurations, each server or each system you have to configure. First you need to install required softwares and configurations here before you deploy that package. So again manual configuration will lead to error prone, and again manual configuration will lead to error prone and so much time. But you can overcome these configurations. So suppose you don't want to manually configure these servers with required softwares. Maybe here you have that login code. Here you need to install Java. Maybe here you have a registration code that is developed in Python. You need to install Python software and Python dependencies, like that. Here Tomcat software, Java software, like that. Here you are going to, you can use instead of manually configuring these servers, you can use some kind of a configuration management tools like Ansible. You can overcome that manual configurations. You can have a Ansible playbooks created for doing a softwares and configuration. You can have a inventory. For these servers, this server's inventory, and you can execute respective playbooks to configure against these servers. You can overcome that configurations. But again, even though you can overcome that configuration management problems via configuration management tools, still so many servers, so many operating systems, licensed cost, infrastructure cost will be more. But understand, you don't need a complete system. You don't need this complete system resources to run such a small service here. Here login is deployed separately, registration deployed, payments deployed separately. You don't need that complete system resources to run that small service. Here you will waste your hardware resources, right? You will waste your hardware resources or system resources. Let's say this the capacity of the system is, let's say, 4 GB or 8 GB. This system capacity is 8 GB RAM memory. Let's say this system has a 4 CPU. But for running such a small services, you don't need that complete system resources. Even though you will overcome the deployment challenges via Jenkins pipelines, even though you can overcome that configuration challenges via configuration management tools, still you have so many servers and your hardware resources are wasted, and so much charges, infrastructure charges if you are using cloud like AWS, so many EC2 instances and charges. If you are using on-prem also, so much infrastructure maintenance and problems will be there. So here you don't need this much CPU, this much memory for running such a small services here. So how we can overcome this again? So this is where the containers came into the picture. So instead of building and deploying your applications as a virtualized deployments, you can build and deploy your applications as a containers. So containers will shine for a microservices architecture. So if you remember that point, containers will work very well for microservices architecture. Microservices is the best way you can deploy the microservices is a containers. Containers is going to shine for a microservice. It is not mandatory, but it is going to work very well together. It is not mandatory that you have to deploy microservices as a containers. You can run in a virtualized deployment, but microservices, the best way to deploy is containers. This is where containerization concepts you can use. That is where Docker comes into the picture. So here, instead of deploying these packages in a virtualized deployment this way, what you can do, so this you can break down to the containers. Let's say with the help of docker you can create a container images. So for each microservice can be built and deployed as a container. This is your application code, but along with your application code or application package, you can build a package with required softwares and configurations also. You write a Docker file, you take whatever base image you need for this one, maybe this UI, you can take Nginx as a base and you can copy all your HTML code on top of that. So using this Docker file, you are going to build a Docker images. You are going to build a container images or a Docker images here. So you will build a Docker image with required softwares and configurations. Like you can have a Docker image with required softwares and configurations here. Required softwares and configurations here. Required environment. You can take whatever base like Nginx, Java, Python, Tomcat according to the requirement. And on top of that, you will have your code, your application code also. So on top of that, you will have your application code. So you can build a Docker image. You write a Docker file according to the requirement of that application. You create a Docker image. You create a Docker image with required softwares and required configurations for that here. So you build a Docker image. So whenever there is a change in this code, you get the latest code, you create a package, then create a Docker image. These images you can store in the artifactories. Similarly, you have a Docker image for this login microservice, registration microservice, payments microservice, orders microservice. Like that, you can have a Docker images. So now you are building a Docker images with required softwares and configurations. Now you no need to use configuration management tools. So now you no need to use configuration management tools again, because you are building a package with required softwares and configurations along with your code, your application code, or application package. So here you no need to use configuration management tools. With the help of Docker, using Docker file, you are building an images with required softwares and configuration. This images you will store in the Docker repositories. For this microservice, you will have a separate Docker repository that can be in the Nexus or a JFrog or ECR or GCR, and you can maintain these Docker images, and you can deploy these applications as a containers. So here, the containers, each container is isolated from other container. You can run multiple applications. You can run multiple applications or a multiple process as a containers in the same system. Here you don't need these many systems again. You don't need maybe 33 servers again. Maybe just in one or two servers also you can deploy multiple. So here all you need is a server with some high capacity. You will have a OS here, operating system. The only required software here is Docker. Only required software in this system is Docker. Using Docker, you can pull these images and you can deploy this as a containers. Let's say this is your UI container. This is your UI, and this is your login container. That container contains everything because you are deploying that from image. So let's say this login container will have that login related microservice running. Let's say this is your registration related microservice. Registration related microservice, right? And again, this is your payments. So here there is a networking in the Docker also. There is a networking. So one container can communicate with another container using networking, Docker networking, right? So this UI can internally communicate with login. This UI can communicate with registration. It can communicate with payments. This can talk to in other microservice, and this can talk to the respective databases also, like that. Here you can overcome that again deployment challenges with the containerization technology. You can build a container images for these microservices and you can deploy them as a containers here. So in a same system, you can deploy multiple applications, multiple containers. Each container is isolated from other container. So you are building and deploying this, the other containers will not impact. They will continue to run here. So you can reduce the infrastructure charges, and you can reduce the maintenance problems, deployment problems also by going with containerization technology like Docker. You can use Docker here. And again, instead of manually building these type of container images, instead of manually pushing these images to the Docker registries, instead of manually taking this image and deploying in these dev servers, production servers, you can have a pipeline. You can have a pipelines created for building and releasing those applications also as a containers also. You can create a pipeline. So you can overcome all these challenges, all these drawbacks with these containerization technologies, CI/CD tools, like that. You no need to use again configuration management tools like Ansible here. Suppose you wanted to do some kind of a OS patches, maybe you can use Ansible, but for application installations, configurations, you don't need Ansible here, like that. So here you can use this containerization technology. In less servers only you can deploy. But again, here also understand one more important point. Suppose you are using only Docker, only containerization technology, only Docker standalone mode. Let's say something goes wrong with this container. This container will not be recreated. Automatically it will not come. Or something goes wrong with this system, hardware failure or a network failure, all these applications deployed as a containers will not available or accessible. So this is where you are going to use container orchestration technology, container management tools. Instead of directly creating a containers, you are requesting container orchestration tools, container management tools. Container management tools like Docker Swarm or Kubernetes or OpenShift, because they are going to manage these containers, and we will have a lot of other advantages also. Scaling, container scaling, container load balancing. If you are using only Docker, if you are using only containerization, you can't scale. Instead of one replica, I wanted to have a 3 replicas. And again, if I have a 3 replicas or 4 replicas, there should be a load balancing between these containers again. I need a container load balancing, and I need a container scaling, and if something goes wrong with this has to be recreated. So we don't have these type of features in a containerization technologies, only Docker. You can use the container orchestration tools like Docker Swarm or Kubernetes. They will create and manage the containers, and we can scale in, scale out the containers. There is a container scaling, container load balancing. You are going to have something called a cluster. You will bring a cluster concept, a group of servers, like a Docker Swarm cluster or a Kubernetes cluster. This is where container orchestration came into the picture. This is how the technology got evolved over a period of time. Docker Swarm or Kubernetes comes into the picture. Here you will have a group of servers. In this cluster you will have a group of servers, not single server. Here there is a master and slaves concept is there. That a Docker Swarm is a master or a manager, or Kubernetes if you are using, that is a manager. So that a Docker Swarm or Kubernetes, like that, you will have a master and a slaves concept here will be there. So you will have a Docker Swarm cluster or a Kubernetes cluster. In this cluster you will have a group of servers like a master server, worker servers. So you are requesting this master to create a containers and manage the containers in this cluster, in this group of servers. So you are requesting this manager like a Docker Swarm or a Kubernetes. So you are going to request to create and manage the containers. We are requesting this. So this will create and manage the containers in this group of machines. You will have a multiple machines. So you can scale. Also here there will be a container load balancing, container scaling. Here you can have a more replicas. And again, if something goes wrong with this, again one microservice can communicate with another microservice. If there are more replicas, there will be a load balancing, container load balancing, container scaling. Like that, you have so many features here. And advantage with this, if it is not a single point of failure here. Let's imagine if, let's say, something goes wrong with this container. This master will recreate that container again. We don't need to do anything. If something goes wrong with this system itself, these containers will be rescheduled or recreated in another system. So you can overcome this container scaling, container load balancing, container management using container orchestration tools like Docker Swarm and Kubernetes, like that. This is how the technology got evolved. So we have a container scaling, container load balancing. Again, one microservice deployed as a container can communicate with another microservices. Again, using service discovery concept is there, DNS. So here you will have a single DNS name for these microservices. For these payments related microservice, you will have one service name. So this one can talk to that containers using that service name. And again, if there are multiple containers for that service, there will be a load balancing also. Container scaling, container load balancing. You don't need to worry about IP addresses of these containers or systems. Everything will work as a service discovery, load balancing. All these features are there. So you can overcome that deployment challenges. Again, instead of manually deploying that in the cluster like Kubernetes or a Docker Swarm, via pipelines also you can request this Docker Swarm cluster or a Kubernetes cluster to deploy whatever services whenever there is a change. Like this, you can overcome these challenges, deployment challenges with the technologies. This is how the DevOps got evolved. This is how the software development lifecycle got evolved. This is how the development and operations teams using all these tools, technologies together in order to build, in order to deploy, in order to release and maintain the applications in very quick way with the best practices also. So we can overcome all these deployment challenges this way. And here the one more problem is communication. One microservice has to communicate with other microservice here. Since everything is now independent services, you have to carefully handle the request. You have to carefully handle the requests traveling between your services. But anyhow, that application team, the development team will write the code. So this GUI will internally have a code. It will make a call to this microservice, like that. And maybe this will talk to this can talk to other microservice, this can talk to one more microservice. They will have that code here. So they will handle, no problem here. And one more important here, integration testing is difficult. Testing a microservice based application, testing a microservice based application is cumbersome, difficult. In monolithic architecture, it was simple, right? In monolithic architecture, everything in same code. You are building this package, deploying one package in some servers, and make sure this has a network with a database. So you can test end to end. But in case of microservices, before you are testing, integration testing or end to end testing, before integration testing or end-to-end testing happens, right, you need to make sure all of your microservices are deployed. You need to make sure each of the dependent service is deployed before integration testing happens. Suppose you have not deployed some microservices. Maybe if you have not deployed this payments microservices, you may able to access login pay, but payments will fail. Suppose if your registration microservices is not deployed, then the registration features will not work. But here you need to make sure all of your microservices are deployed before testing happens. But here, instead of manually building and manually deploying, for each microservice, you can have a separate build script, separate deployment script, separate pipelines also, so that you can do the automation here. So this is how you can overcome this. The next biggest challenge here is debugging. The next biggest challenge here is debugging becomes harder. Here, each microservice has its own set of logs. Last time, your login, your payment, your registration, your orders, all the logs are in a same log file. But now, you are deploying in a separate. So here, you will have a UI logs. Here you have a UI logs. Here you have a payments related microservice logs. Here you have a payment related logs. And here you have a login related logs. It is not in a single place. Now internally, this is talking to this one, this is talking to this one, this is talking to this one, this is talking to this one. I don't know where exactly it is failed. I don't know where exactly it is failed. I need to trace the error. So here, debugging and tracing becomes a problem. Debugging and tracing becomes problem in this microservices architecture. It is not easy to go to here. We have deployed in a distributed environment. Our application is deployed in a distributed environment, right? It is not in a single server. It is in a multiple servers again, and multiple containers are there here. So it is a distributed. Our application is deployed in a distributed environment. So here, where exactly it is failed, it is very difficult to check. Here you need to check this log, maybe again check this, or again check this, check this. It will take so much time. You need to go to so many servers. You need to check this server logs, this container logs, like that. It is very difficult. But this also we can overcome. This also we can overcome using log aggregation and log monitoring tools. These logging and debugging problems also you can overcome using observability. There is something called observability. Observability will have a metrics logs also. Logs I am talking here. So here SRE, that SRE job, System Reliability Engineering. So the SRE main focus is observability, right? Collecting the logs, aggregating the logs, monitoring the servers, containers, clusters, like that. That SRE related. You can use log aggregating and log monitoring tools that comes under SRE, Software Reliability Engineering. So like you can use, maybe you might heard something called Splunk. You might heard something called Splunk, or maybe you might heard something called Elasticsearch. So these are like a log aggregation and log monitoring logs. This is log aggregation or a log aggregation or log monitoring. These are going to collect the logs. Metrics is different, logs are different. Metrics is like a monitoring, CPU metric, memory metrics of these containers or systems. That is different. So here you can use this type of log aggregation and log monitoring tools. So here you no need to go to each and every server, each and every container to check the logs. Here you can deploy the log agents in whatever systems you have deployed your applications or services, right? Whether it is a server or a container, that doesn't matter. Here you can deploy the log agents. Suppose you are using Splunk, you can install Splunk agent. Or suppose you are using Elasticsearch, you can install that Elasticsearch agent. Suppose in Elasticsearch you can use Logstash as an agent, or maybe you can use FluentD as an agent, log agent. Anyone, either Logstash you can use as an agent software for collecting the logs, or maybe FluentD as an agent. So this you can install these log agents in your systems from wherever you wanted to collect the logs. So here, when you are installing this agent software, you can configure like from where it has to collect the logs. Here you will have a where messages. This is your system logs. This is your system logs, and that applications, that containers also will generate the logs. You can configure all of the containers in that system. It will be in this containers, where log containers like that. So you can configure these agents to collect the logs from these locations in that system logs or container logs. It can collect. You can configure these agents to collect the logs from these systems or containers. So what these guys will do? These agents will collect the logs, your system logs, your container logs. This will help you for troubleshooting and debugging the application request failures. Now these agents will collect the logs here, and there is a centralized log aggregation tool. There is something called, in case of Splunk, that will Splunk. In case of Elasticsearch, you can have Elasticsearch. This is going to collect the logs from all these agents. This is going to collect the logs and index the logs. This is going to collect and index, log aggregation and log indexing. So this will contact this. This will contact these agents, and it will collect those logs. It will collect those logs and store the logs. And here you can use one more tool called Kibana. You might have something called ELK stack or EFK stack. E stands for Elasticsearch, K stands for Kibana, but L stands for Logstash, or maybe instead of Logstash you can use FileBeat or FluentD. Here you can use one more tool called Kibana. So this Kibana is like a UI to search the logs. So this Kibana can talk to the Elasticsearch. And suppose as a developer or as a DevOps guy, you don't need to go to each and every system and each and every container like that. So you can search the logs. You can search the logs via Kibana, right? So this Kibana will internally talk to Elasticsearch. This Elasticsearch has collected your system logs, your container logs from various sources and indexed here. So this is how we can overcome that debugging or tracing problems. So end users are accessing, these applications are generating the logs. This will talk to this one, this will talk to this one, like that. But these will collect the logs from these locations that is stored here, so that it will become easy for debugging and troubleshooting. So that is how we can use this log aggregation and log monitoring. But metrics is different, logs are different. Metrics means the CPU metrics, memory metrics, cluster metrics, like that. So you can use monitoring tools for that one. Observability, monitoring tools. You can use monitoring tools like here. You can use monitoring tools like Prometheus. Prometheus is a monitoring software. Grafana is a visualization software. So here you can install monitoring agents also. Suppose you need a node related metrics, like what is the CPU utilization of your server, memory utilization, how much storage is there, how much is used, like that. So monitoring also very important. That is SRE, site reliability engineering. We need to make sure our site is reliable and accessible. So we have to continuously observe what is happening in the servers and the containers and applications, like that. So here you can use monitoring tools like Prometheus. So Prometheus has so many agents, like a node agent. Suppose this node agent, there is something called node exporter. This is an agent for Prometheus. This is going to collect the metrics like a CPU metric, memory metrics, network metrics, all these metrics from this server. And you can install this node exporter in each and every node. Whatever nodes you wanted to monitor, you can install that monitoring agent software in all the nodes, whatever you wanted to monitor, like this. Whether you are using virtualized deployment, whether you are using a containerized deployment, you can use this Elasticsearch monitoring tools like that. Then there is a Prometheus. This Prometheus will collect the metrics from these targets. Prometheus will collect these metrics from these targets. So this Prometheus will contact these agents. That agents has collected the node metrics like CPU utilization, memory utilization, network utilization from this, right? This will collect. But Prometheus, using Prometheus, Prometheus is going to collect the metrics and store those metrics. Based on the collected metrics, you can trigger the alerts also. You can trigger the alerts. You can create alerting rules. You can create alerting rules like if server is down, send the alert. If server is down, send the alert. Alert to the application team, support team. If CPU utilization is greater than 90%, send the alert. If memory utilization is greater than 85%, send the alert. So this Prometheus will collect the metrics from various targets using these agents. Based on the collected metrics, you can create alerting rules so that this Prometheus will send the alerts. Alerts means notifications. So before your system is impacting, before your applications are impacting, before your customers are going to impact, if you are getting the alerts or notifications, you can go and troubleshoot and fix the problem. So you can overcome all these things using tools. So this is how Grafana is not a Grafana is not a monitoring tool. Grafana is like a visualization tool. Using Grafana, you can create a dashboards, nice dashboards, what is happening inside the server or a cluster. This Grafana will take the metrics. This Grafana will take the metrics from monitoring tools like Prometheus. So you can see in a nice UI. So this DevOps team or development team, you can understand what is happening in this server or this server like that, you can see. So you can use all these technologies, tools to build and deploy and maintain and manage or monitor the applications. So that is how the technology got evolved. And here the application team is developing the applications as per the requirement. They are maintaining that in a SCM repository, and using build tools, you are building an application package. Using Docker, you are creating a container images. Those images you can store in the artifactories like Nexus, JFrog, ECR, GCR. Then you can deploy those images as a containers in the clusters like a Docker Swarm or Kubernetes, and it will schedule the containers and manage the containers. There is a container scaling, container load balancing we have. If something goes wrong with this, it will recreate. If required, you can scale in, scale out the containers. There is a load balancing and observability monitoring. You can collect the logs and index the logs and query the logs via log monitoring and log aggregation. You can monitor what is happening in the servers, clusters, applications via monitoring tools. So this is how the technology got evolved. So whatever I have explained today, if you understand the concept, so you can understand the complete picture of the application development and the deployments and observability, and how a DevOps engineer, a DevOps guy will fit into this life cycle. So developers will do their work, DevOps guys are doing our work. So now you can easily understand the complete picture of the application deployment process, build and deployment monitoring process here. So DevOps is not a single tool. DevOps is not a single technology. DevOps is a culture. DevOps is a methodology or a strategy where various teams will work collaboratively together in order to build and deploy and maintain the applications very quicker, fast feedback with the best quality. Suppose as a DevOps guy, you are going to create a SCM repositories for these microservices, and you are going to manage the permissions to the respective team. And as a DevOps guy, you are responsible for creating a CI/CD pipelines for each microservice. You are responsible for creating a Docker files and building images. And you are responsible for doing a code quality checks, code coverages. You are responsible for creating a repositories like Docker repositories, And you can use infrastructure. You need a servers. These servers can be in on-prem, or you can use cloud services like AWS or Azure or GCP to provision the required servers and storages and networks. And here you can deploy and manage your applications like this. So even though we are not developing the application here, as a DevOps guy, we are not developing the application, but understanding the application play a very important role, how you can implement the operations for that. Suppose you are not developing, but you have to understand the application design or a system design and application architecture, so that you can easily work on any application or any project on DevOps. That can be creating a CI/CD pipelines, that can be building and deploying your applications as a containers in Docker, Swarm, Kubernetes, or whatever, creating a required infrastructure in the cloud like AWS or Azure or GCP, whatever it could be. So if you understand today's session, the monolithic and microservices architecture, and the build and releases and maintaining and monitoring, you can understand the complete DevOps, and you can challenge whoever has a real experience with 5 to 6 years of DevOps knowledge also. You can challenge them, even they don't know this much details. I have not considered your experience, whether you are a fresher, whether you are a junior DevOps guy, whether you are a senior DevOps engineer or a team lead or a manager. I have not considered your experience. I have tried to share my complete experience. I have a 15 plus years of experience in IT, in system designing, building, deploying, maintaining. I came from a development background. I started my software journey with a developer, Java development. I have developed, and also later I moved into cloud DevOps. Right. So I have shared my complete experience of my knowledge in today's session, so that you can understand whether you are a lead, whether you are an architect, whether you are a junior DevOps guy or a senior DevOps guy. If you understand these concepts, you can easily manage. You can easily manage your application. That can be any critical, real, very big application, enterprise application also. But you have to understand the concepts. So why we are using Git we are using for maintaining the source code. Why we are using Docker? We are using Docker to create and manage the images, required softwares and configuration. We are going to use Kubernetes or a Docker Swarm for deploying and managing those, so that you can scale in, scale out. You are going to use servers and storages from cloud or AWS or GCP or maybe on-prem to set up the required infrastructure. And you can use monitoring tools for observability, all these things. And security checks in the early stages of your application. First, you can check the source code quality using SonarQube. You can check the code coverage, and you can scan your container images also. DevSecOps. I am trying to explain SRE concept and security concepts also here. Source code quality check, image scans, that is comes under security. If the security is failed, that security checks are failed, vulnerabilities, don't proceed further for deploying. Fix that. And if code quality is good, code coverage is good, scanning is done, then you deploy those packages in your systems like that. So if you understand today's session, you will understand the entire application and its architecture and its designing. You can apply these concepts or a knowledge to explain your project architectures also. Someone will tell you, can you explain your project architecture, your system designing? So you can easily explain. You can challenge a person who already has a 5 to 6 years of experience also. You can challenge. But only today's session may not help you. First of all, if you don't know what is Docker, how to write a Docker files, how to create an images, then what is Jenkins, how to create a pipelines. If you don't know what is Kubernetes, how to create a deployment services, config map, secrets, volumes, how to set up the cluster. If you don't know, you may not able to do anything. But I am saying, if you understand today's concepts, and if you understand the DevOps tools like Jenkins, GitHub, Docker, Kubernetes, Prometheus, Grafana, you can easily manage any project with 5 to 6 years of knowledge also, guys. I hope you got a complete picture of the application and its architectures, and how the developers will work, how these DevOps guys will work and use these tools for all these integrations, deployments. This is a real project use cases or a real project scenarios. I hope you are very clear about whatever has been discussed in today's session. But without having a detailed knowledge about Docker Swarm, Kubernetes, and again Jenkins and Docker files, which we have already discussed in the regular training. We have discussed all these things in a regular training, right? So in a regular training, I have explained what is Docker file, how to create a Docker file instructions, how to build images for Node.js application, Python application, the best practices we have discussed, and we have discussed all these things. Anyhow, in regular classes, I will explain Docker Swarm, Kubernetes also, and Prometheus, Grafana also, and so that you can apply this knowledge for any applications or projects. Okay. Thank you, guys. That's it for today. Right. I hope you are very clear about whatever have been explained today with this system designing or architecture.